Now we will come to the main thing, that is we will discuss about the RL. We have already discussed about RL circuit. Now we will discuss about the RC circuit. RC circuit, C and R. Okay. And what is the reactance of the capacitance? XC.
1 by j omega c.
Okay. I can say the JXC is nothing but, yeah, or I can say it's the reactance is 1 by j omega c. Okay, this is the, and I have the input same like V of t, which is having the same form. My input is having the same form. I will use another color. It's better. Okay, I will use this color. My input is having the same form as I told you. My V of t is Vm sine omega t plus phi. Okay, if it is like this,
Sir.
I am going to measure the current. You know that the structure of RL circuit and RC circuit is same, except there is only one thing, the time constant in RL circuit. What is the time constant? It is L over R. And what is the time constant here?
RC.
That's it. So all the equations will be same because the differential equation is same. So everything will be same, right? So the structure will be same. The whole structure will be same. So you can easily handle this thing. So what will be the, okay, so what will be the output? The output will be minus Vm divided by square root of R square plus, instead of omega L, what it will be?
1 by omega c.
Yes, it will be 1 by omega c. It will be 1 by omega c, right?
Yes, sir.
Okay. So we can do one more thing. Okay, we can do one more thing. It's square plus
Maybe it
1
will
bar.
take a minus sign, sir, because the
There
j
will
is
be a,
denominator.
okay, there will be a small issue that we have to solve. First of all, you have a R, you have C, and you know it's V of t is nothing but V of t is equal to Vm sine omega t plus phi. So what is this? Is C. So this. So what will be the total current I of t? I of t is nothing
V
but
of t by
V of z,
R.
right? Yes. So V of t is V of t divided by z. And what will be z? Z is nothing but R plus,
Plus
okay,
1 by c.
yes, R plus 1 by j omega c, right? It's 1 by j omega c, right? Now in Laplace transform also I can do the same problem in Laplace domain. What will be my uh, transfer function here? Input is the voltage and output is the current I. So what will be my transfer function? H of s,
1 by
out, yes, I of s by V of s. This is my transfer function. Am I correct? Yes.
yes,
So
sir.
I of s by, that means it is z of s, right? This is nothing but 1 by R plus 1 by SC. Okay.
Yes, sir.
Oh, okay. 1 by SC. So we can write it in another way also. Yes. So what will be if I talk about the
1 by RC plus
mm, Yes. So we can
C
talk
will
it
be in the numerator.
Mm.
Then by RC plus uh, uh, S, I think. RS plus S.
Yes. Okay.
No,
That's it.
RS plus 1.
Yes. So it will be h of j omega. We will talk about h of j omega. It is nothing but 1 by r plus 1 by j omega c. Okay. Is it okay?
Yes, sir.
So it will
Yes.
be equal to 1 by 1 plus j into r omega, sorry, j into omega into r into c. Is it okay?
Doctor,
And the j
L,
omega will be the right, like this. Is it okay?
doctor,
Yes.
why we always substitute in H J omega?
Sorry?
Why why are we always substituting S equal
Yes.
omega?
Yeah. We are finding the frequency response of the system. We are mainly focusing on the frequency and the gain of the system. Okay, that's why we are substituting like that. Okay,
Yes.
nothing else. So you are talking about, now we are talking about this one. So what will be the magnitude of this guy? What will be the magnitude? The magnitude of h of j omega. H of j omega will be equal to, sorry,
The
the
magnitude of
magnitude,
the numerator.
yes, is equal to, what will be the magnitude? The numerator magnitude, what is the numerator magnitude? It is nothing but omega c, right? And divided by square root of 1 plus omega rc whole square. Is it okay?
Yes,
This
sir.
is the
Yes.
magnitude. Yes. And what will be
It
the
will be the
phase?
power of J. It will be minus 1, right? J
Which
square, it
one?
will be minus 1.
How? You first go and study the high school mathematics. You see here x plus jy. What is the magnitude of x plus jy? It is nothing but x root of
X
x
square,
square
yes.
plus y square. Is it okay? Is it okay? Majid?
Why, doctor? It's the first one square plus the first one square plus the second one square, all
What is
under
x,
the root, right?
x plus jy?
الجي ما يدخل في السكوير روت.
This is your x plus y. Suppose this is the real axis. You have a, these basics I cannot explain always. That's the problem. See, I have the imaginary axis and I have the real axis. Okay. So I have jy here and this is x. So I have a point here and this point is x comma y, right? Because this is the imaginary axis, means j. Okay. And this is y. So this is the vector. This is your phasor. What is the magnitude of this phasor? In this direction you have x. In this direction you have y. And you know this will be equal to square root of x square plus y square. So that is the magnitude.
Yes.
And what will be the phase of this? Tan inverse y over
Y by
x.
x.
There is no j here, okay? J is representing, j is giving you an idea. Your
Only the
real,
direction, right?
yes, it's giving you 90 degree. That's it. The j, the
Yes.
meaning of j is 90 degree. What is j? J is nothing but
Square root
e
minus 1.
power j 90. What is e? Sorry, it is nothing but e power j 90. E power j 90 is nothing but cosine of 90 plus j sine 90. And what is this? Cosine of 90 is 0 plus j and sine 90 is 1.
1, yes.
So what is the angle of this? It's giving you 90 degrees. That's it. That is the meaning. It is having a phase of 90 degrees. Okay. So
Okay.
what I'm going to say, it is having an angle which is equal to, what is the angle of the first term? Y by x.
Come, sir.
X is equal to 0. tan inverse, that
Zero,
means tan inverse, what is tan inverse infinity?
90.
Tan inverse infinity, right? It's
What are you talking about, sir? Which one?
tan inverse infinity is 90 degrees, right? Tan inverse infinity
Yes.
is 90 degrees. So it's pi by 2 actually, pi by 2. And what it will be, this one. What will be the
tan
phase of this?
inverse,
Yes,
omega
tan
RC.
inverse omega RC, right? That's it. You got the point what I'm saying? So you can use here.
Sir, J omega
Yes.
C, how do you know it is pi by 2?
What is j omega c? I am not understanding why you are having this type of confusion. X plus jy. It's tan inverse y by x. What is x here? It is 0 plus j omega c.
Yes, x equal to 0.
So y by
Yes.
x, omega c by 0, it's infinity.
Yes. Infinity.
Tan inverse infinity is 90 degrees. These are all high school mathematics. Okay.
You're right, sir. You're right.
Okay. I will kick you. So
No, I'm sorry, sir.
So this is pi by 2 minus tan inverse omega RC. So you have got the magnitude and the phase. You understood? If you get the magnitude and the phase, is it easy here to substitute? Yes, the magnitude is, you see here, it's having a magnitude which is, omega c by 1 plus omega RC square. Okay, so it will not be r square, it will be 1 plus omega RC the whole square into omega c. Is it okay? The magnitude is on.
Yes.
And I am not, there is no minus sign here. Okay, I will talk about the steady state output now first. Steady state output current, ISS of t, and sine of omega t plus phi. You have already this. Now what will be the phase contribution? Pi by 2 minus tan inverse omega RC.
Tan inverse
So plus pi by 2. I have no space here, that's why I'm writing here. Tan inverse omega RC. Okay. So this is the phase of the circuit. Okay. So this is the steady state output. And you know the transient state is like, excuse me, 1 second. Okay. Just somebody
Take
has
your time,
kicked.
sir.
Excuse me. I think you can hear me, right?
Yes, sir.
Okay. The transient will be in the same form. Actually, it is nothing but k into e power minus t by tau. Is it okay? Transient state will be in the
Yes,
same,
sir. Yes.
because we will be getting the, but tau will be here, it will be r into c, right? Tau will be r into
K
c.
will be same,
That's,
sir.
k will not be same. We have to find out the k, because we have to find out the k.
Yes.
So is it possible to find out the k here?
Yes, sir.
Because at t equal
Because
to
the
0,
current
suppose,
in the initial state current it will be V of t by R. We found it before.
is it possible? At t equal to 0 minus, at t equal to 0 minus, at t equal to 0 minus what will be the current I of t, I of 0 minus?
V of t
will
by
be
R.
0.
T will
0.
be equal to 0. And at t equal to 0 plus, what will be the current?
Same.
Is it, what will be the current? I of 0 plus, what will be the current?
Should be 0 also.
No,
No,
that is the
because
problem.
the capacitor can change the current instantaneously.
Yes, the capacitor can change the current instantaneously. Capacitor can change the current instantaneously. You understood? So is it possible to go
Yes,
by
yes,
this
sir,
method?
yes.
Is it possible we can go by this method or not? What you are saying? We have one
No,
information.
not this
Capacitor cannot change the volt. So this method, that's what I am saying. This is what I want to tell you now. This method, that is just by
Simple
finding that, yeah, this method will not give you the correct way. Okay. So what we can do now?
I think we can find the I
So
0 plus
this method also,
by
this
Ohm law,
method also,
V of
this
t
also
by
will,
R.
this also will not work. So whole method actually, what I have written now, it will not work like in inductor. Then what we have to do? That's what I am going to explain.
Why, sir?
Why it is not working? Because if you want to find the complete solution, you have to find k, right? You have to find k here. But for finding the k, if to find the k, you have to make the current 0, right? You have no idea about the current in the
Yes,
at t
sir.
equal to 0 plus. Is it any way to get the current at t equal to 0 plus? It is very difficult.
By time
So
equal
finding,
infinity.
sorry,
By time equal
at,
infinity, the current will be 0.
but if time become infinity, this factor becomes 0, right? This factor becomes 0 as t tends to infinity. Since that factor is becoming 0, you cannot find k, because k multiplied with 0, if something is multiplied
yes,
with
sir.
0, it's difficult to find that value.
Yes, you are right,
You
sir.
know, 2 multiplied with 0 is equal to 0, 3 multiplied with 0 equal to 0. So it can be 2, 3, any value. It is not a specific value, right?
You
So
are
it is
right,
difficult
sir.
to find. Yes, that's why. So it is difficult to find the solution. Since it is difficult to find the solution, I am going through another way. Okay, so you have a circuit like this. This is your R, this is your C, and you are giving an input V of t, which is equal to Vm sine omega t plus phi. Okay, and this is your circuit like this. Now I will find the capacitor voltage. Now you may get the idea why I am using the capacitor voltage. I am going to find the capacitor voltage,
Cannot
because capacitor voltage at 0 minus and 0 plus will be same, right? This is the trick. So I will play with the capacitor voltage. If you know the capacitor voltage, you can find the current easily, because you know the current through the capacitor I of t will be equal to C into dVc
by
of t. Yes,
yes,
you just
yes, you are
differentiate that answer. So you can find the current after finding the capacitor voltage. So how to find the capacitor voltage? We will take the Laplace transform of each. This is 1 by SC. So I am going, my input is nothing but V of t. Output is nothing but, what is my output? Capacitor voltage, right? I am focusing on
same
the
as
capacitor
previous.
voltage. Yes. So what is capacitor voltage? So what will be my transfer function? My transfer function, which is nothing but h of s, is nothing but Vc of s divided by V of s. This is my transfer function. Now output by input. Okay, this is my output and this is my input. You should be very careful about this kind of things. Okay, don't say that the capacitor current before 0 minus and 0 plus is same. We have no idea about it, okay? But we have an idea that 0 minus and 0 plus will be having same voltages. So that is the only key point. So that we have to be very careful. So what will be H of S? So VC of S, we can find VC of S by using voltage division. What it will be? It's V divided by R plus 1 over SC. You have to multiply with 1 over SC, right? It's simple voltage division. Am I correct? Yes. So
Yes.
from this equation,
sir.
we can easily find, just to rearrange this equation, VC of VS, sorry, VC, actually it's VC, yes, VC here. So VC of S by, yes, this is nothing but 1 by SC divided by R plus 1 by SC. So this become, just to simplify this, it become 1 plus R 1 plus SCR, it will become, because SCR, I will write like this, or SRC, no problem. Because 1 by SC is there, SC is there, it will cancel, it will come in both denominator and you will get something like this. Is it okay?
Yes.
So I got my transfer function. Now H of S is equal to, H of S is equal to
Doctor,
1 by,
excuse me.
yes,
Can you back to the previous one? I have one there. V of t here, when you find V of C of S,
yes.
you use
Hmm.
V of t. Why not V of S, sir? Is it for the
Oh,
same
yes,
reason?
yes,
Because one frequency.
yeah, it's no, it's my mistake actually. I have it has to be V of S. Okay, sorry, thank you for it. I have used here actually. This is my mistake, writing mistake. Okay, please tell me if I made this kind of mistakes. Okay, it's my writing mistake. Okay, so H of S is nothing but 1 by 1 plus S into. So what is the magnitude of H of S? I will just put S is equal to j omega now. I am going to put H of j omega. Now H of j omega, I want my frequency response. So 1 by 1 plus j omega into R into C. So what is my magnitude of H of j omega? Magnitude of H of j omega is 1 by square root of 1 plus omega RC the whole square. And what is my angle of j omega? It is nothing but the angle of the numerator. What is the angle here?
0.
It's nothing but 0. And what is the angle here? That's it, 0 minus. So it will become 0 minus. So 0 minus tan inverse omega RC, right? By 1. That means tan inverse omega RC. I got it now. So my output will be my VC of t. Now I can write like this. I have my input. I will first write my input, sine omega t plus phi. This is my input. So first to write the input. And what is happening to the magnitude? It is having a factor, it is having a gain 1 by. That means into 1 by square root of 1 plus omega RC square. And the phase is 0 minus, that means minus. So minus here tan inverse omega RC. That's it. So I got my steady state output. This is my steady state. So the actual total steady state voltage across the capacitor. So the steady state voltage across the capacitor will be like this. Okay. But I have a problem here. The steady state voltage is not enough for us. I have the complete response. I need to find the complete response. And you know that V of t will be taking a form of transient. Is transient means you just solve equation, differential equation. Okay, source free, without source. That means you know the solution is e power minus t by tau. Tau is RC, right? Plus, yes, this is my voltage across the capacitor. Complete solution. Complete solution. So the other part is Vm by square root of 1 plus omega RC. the square, then sine omega t plus phi minus tan inverse omega RC. Okay, now I can find k because at t equal to 0 minus, the voltage across the capacitor at 0 minus was 0, right?
0.
Then
Yes.
at t equal to 0 plus, it will be same.
Also 0.
Yes, capacitor cannot change the voltage. So I can use this. I will take at t equal to 0, at t equal to 0, my voltage Vc of t at 0, Vc of 0 is nothing but, it will be 0. This is nothing but k into e power minus t over Rc plus, you know this, other part is Vm by square root of 1 plus omega Rc, the whole square, into sine omega t plus phi minus tan inverse omega Rc. Okay, now what k?
Yes.
So you know this guy.
Minus Vm by 1.
No, what will
whole.
happen to e power minus t by Rc? It will become 1.
Oh,
Okay,
yes.
this become 1 because t equal to 0. So
Yes.
k will be
Yes,
equal
sir.
to minus Vm by square root of 1 plus, you have to put this guy t 0 also. So omega Rc, the whole square, into sine of omega t becomes 0.
By
So minus tan inverse omega Rc. This is the value of k. Now you will get complete solution for this case as Vc of t is equal to complete solution. Okay, complete solution, not steady state. It's minus Vm by square root of 1 plus omega Rc, the whole square, into sine of phi minus tan inverse omega Rc into e power minus t by Rc plus the remaining part, steady state. Okay, Vm by 1 plus omega Rc, the square, into sine of omega t plus phi minus tan inverse omega Rc. So this is the output. The voltage across a capacitor will take this form. That will be exactly this form. It will take this form. Now if you know this voltage, you just differentiate and multiply with C. What you will get? You will get the current. It's very easy, right?
Yes,
Since you know Vc of t, you take the differential of this guy and multiply with C, and you know this everything, the current is same, so you will get the current I of t. This is the complete solution. I am not going to write it. Okay, it's a big answer. So this
okay,
will be okay. Now we will see for transient free.
Doctor, I have a question.
For yes,
If the switch open
yes,
at t equals 0, do we
yes.
have VSS or not?
If we are opening the switch, there is no meaning actually. We are opening the switch means we are not applying any AC input. The capacitor is already charged to some voltage, then it is a DC response with source free response.
Yes.
You understood?
Yes.
The capacitor will be charged to some voltage if you give some AC before, and you are opening the switch. And if you are opening the switch means there won't be any current. If you open the switch, the capacitor will stay like that. The capacitor will not discharge, actually, ideally speaking.
It will charge until it became like the
It will
source.
not, actually, it will not discharge, actually. Okay.
Yes.
Ideally speaking, but there will be a discharge in the capacitor because I have told you the capacitor is having a model, actual capacitor is having a resistor in parallel. So because of this, it will discharge like this. And finally, after some time, the voltage will be 0. That is another issue. Okay.
Yes.
So that's it. Now we will talk about the transient free condition. Transient free condition. So in transient free condition, what will be the situation? Our k should be equal to 0. Here also we have k. Transient free means what? K should be equal to 0. At t equal to 0, we are talking about you are closing the switch at t equal to 0. Closing switch at t equal to 0. In such a case, what will be the value? You see here, this guy should be equal to, yes. So phi minus tan inverse omega RC, like yesterday's lecture, I have explained you something like this. It should be 0. If this is 0, then phi should be equal to tan inverse omega RC. So you see, yesterday I have written tan inverse omega L by R, right? I have written L by R. L by R was the time constant. Here RC is the time constant. That is the only difference. You understood? So the input is sine wave. Okay, input is sine wave. And transient free case, we are closing the switch at time t equal to t0. It's exactly like yesterday's equation. It will become omega t0 plus phi should be equal to tan inverse omega r. Yesterday's equation, same equation, but note that it is sine wave. Okay, and here also it is sine wave. Okay, sine wave. Now what will be the situation if you have a cosine wave?
Same, but
free.
I think to the right side, omega pi by 2.
Yes, pi by 2 will be there. That's it. So everybody is clear about it? Nobody is responding. That's why I'm asking.
Yes, sir. Yes, it's clear.
Yes, transient free with cosine input. Okay, just cosine omega t plus phi, and you have a switch which is closing at t equal to 0. That is the switch condition. So if this is the condition, then it's nothing but phi equal to tan inverse, same equation. There will be a pi by 2 also here. That's pi by 2, and here also transient.
It is minus, sir.
Minus,
Sir,
I
it's
think.
minus.
Is it minus?
Because already we changed the cosine to sine by adding pi by 2.
Just wait. Yesterday's equation. Let me check yesterday's equation.
Also, previous one was minus.
Let me check it. Is it plus or minus? Plus, right? Is it plus? It was plus yesterday. I have written plus.
If we change sine wave to cosine wave, doctor, or we change it, I mean cosine to sine, we are adding 90, right?
I have told you this matter actually. Yesterday I have explained it. If you want, I will explain again. Just see here. You have actually sine omega t plus phi. If this is the condition, then you have omega t naught plus phi should be equal to tan inverse omega rc. Okay, now you are changing sine to cosine. Okay, you have an cosine omega t plus phi. Now you are changing this guy to sine wave. How you can change the cosine to sine?
By plus pi by 2.
You know this. The cosine can be
Addition
changed
by
to.
2, sir.
Are you sure? Addition or minus? Cosine of this.
No, it is addition, I'm sure.
You see here, sine
from
of
cosine
theta,
to sine.
Sine of theta minus 90. What is sine of theta minus 90? Sine theta cos 90. Oh, no, sine theta sine 90 minus.
This is cosine theta.
This is cosine theta. So sine theta. What is sine A plus B? Sine of A plus B or sine of A minus B. Anybody remember?
Have sine A.
No.
I think something like
no,
that.
No.
Have
No. Sine of A minus B, or sine of theta minus 90 is sine A sine 90, right? No, sine A cos 90, sine A cos 90. Is it correct? Let me check. Sine of A plus B.
I'm not sure, sir, about that.
Can you check? Anybody can check it?
I will now. I'm checking to the internet.
I found a formula.
Yes, please.
It's sine theta equals cosine
Yes.
90 minus theta.
No. I just need sine of A plus B. What is the kanun for it? That's sine of A plus B.
Okay.
Sine of A plus B, please.
Yes, the doctor.
Yes.
Sine theta cosine 90.
Yes, that's it. I was writing the correct answer, I think. Sine of theta cosine 90
minus cosine theta sine 90.
cosine theta sine 90. Okay. Is it okay? Sine of theta minus 90. Okay. So what is this? Cosine 90 is 0. So it's minus
It will be minus cosine theta, sir.
minus cosine theta. Okay. So what will be sine of 90 minus theta? Minus cosine theta. How we can change it?
Make it plus.
Yes, if it is plus, it will be plus cosine theta.
Yes.
Is it? Is it? Okay. So I can write this guy in sine form. In what way? I can write like this, plus pi by 2, right? I can write like this.
Yes, doctor.
So if I am writing this as pi by 2, then what will be the equation? So let me check what I have written yesterday. There is something wrong, I think so. Let me check. If the input is cosine input, what I have written. If the input is cosine, the answer is correct. I checked the answer, but is there any issue in the formula? Let me check one second. So let me write it: sine A cosine B, and sine A cosine B minus cosine A sine B. What will be sine of 90 minus, excuse me, are you with me?
Yes, doctor.
Oh, yes.
Yeah. How we can solve this issue when we are getting a cosine omega t as the function, cosine omega t plus phi? We have to first convert it into sine form. If I am converting it into sine form, then just
We will add
see,
90.
yeah, we will see it will be sine omega t plus phi, sine omega t plus phi, okay, then into cosine pi by 2 plus cosine omega t plus phi. Yes, it's correct, I think so. So it will be nothing but, what will be the answer now? Now we have to get the answer. So yes, it will be minus. If it is so, it will be minus. But I need to clarify whether I have made a mistake in my notes. I will check it, okay? I need to clarify this thing because in my notes I have written as plus
No
pi
problem,
by 2.
sir.
Okay, in my notes I have written as in my notes I have written plus pi by 2. That is the problem.
No problem.
It's in a different way also we can write it, okay? In a different way also we can write it if that is the issue. That's why. Okay, I will explain. Okay, this is, if I am giving an input which is a cosine wave, then I have to find the transient free condition. The transient free condition will be like this. Inshallah, I will explain now after giving you the formula. What is the reason? If I am giving a cosine wave at t equal to t0, then phi, then it will be nothing but omega t naught plus phi should be equal to tan inverse omega rc plus pi by 2. It will get plus pi by 2. What is the reason? I will tell you. Okay, it is because when we are finding, whenever we are finding k, in this case, in this situation, when we find k, if we find k, what will be our output? If I am giving a cosine wave, Vm cosine omega t plus phi, my output, steady state output, what will be the total output? T of t, complete solution, nothing but some k into e power minus t by rc plus Vm, it was scaled by a factor, square root of 1 plus omega rc whole square. Is it okay? Then my output will be cosine,
Yes.
right? If I give cosine, my output will be cosine omega t plus phi. Then I have to include the angle. And what is my angle? And my angle was minus of tan omega, yes, omega rc. So that will be my output if I am giving the cosine wave. And my k will be, and what will be my k if I put t equal to 0? What will be my k? My k will be minus Vm by 1 plus omega rc the whole square into cosine of omega t plus phi, right? Cosine of omega t plus phi minus tan inverse omega rc. This is nothing but, this guy becomes 0, so it becomes cosine of phi plus phi minus tan inverse. So if there is a cosine function, so for k equal to 0 means what? Transient free.
Yes.
Transient free for k equal to 0 means cosine of something, some theta equal to 0, right? Then theta should be equal to what? For cosine is 0, theta should be equal to
Pi by 2, sir.
Yeah, that's the reason. Okay, so I will get my phi minus tan inverse omega rc should be equal to pi by 2. That means my phi should be equal to tan inverse omega rc plus pi by 2. That's why. Okay, I hope it is clear to you. Now,
Yes, sir. Yes.
now if I close at t0, if I close at t0, then it will be omega t0 plus phi. This number should be equal to tan inverse omega rc then plus pi by 2. Okay, So this is the formula. That's what we are getting. Okay. In the previous
Yes.
situation also you can follow like this. Okay. Now, now we will see. So this is the transient free condition. So we have seen now RC circuit and RL circuit, and you know how it will respond according to the AC input. Now we will see what will happen in an RLC circuit. In an RLC circuit, it's very complex. It's not so simple. In an RLC circuit, you know, this is the resistance, inductor, and the capacitor, and you have already studied source-free RLC circuits and all, and also with the source also you have already studied. And we
Yes.
are going to give V of t, which is nothing but Vm sine omega t plus phi, something like this. Then what will happen here? Here the situation is a little bit complex. Now you know that we will first find, I will tell only the procedure. At first step, we will find the differential equation or Laplace transform. We will find the differential equation, or by using Laplace transform, we will find the characteristic equation. Characteristic equation. You remember, I have written a characteristic equation, s square plus some alpha everything. You remember?
Yes. Yes.
Yes,
Yes,
that
sir,
kind of
yes.
equation. Then I will find the root of the characteristic equation, roots. And what are all the roots of this characteristic equation? My root may be S1 and S2. It's nothing but minus alpha. It's nothing but minus alpha plus or minus, sorry, not plus or minus, it's plus J beta. You remember this? I have already told you while teaching the DC transients. So minus alpha minus J beta. So these are all the two roots, right?
Yes.
Sometimes we have do you remember the formula that I have written for the roots?
No, sir.
Okay. If there is complex number in the root, if there is complex number, is there any oscillation? If there is complex number?
Yes, if there is complex number, there will be oscillation.
Yes, complex means you will have oscillation. If no complex number,
Real.
exponential decay, right? Decay. Then, so this is the criteria actually. So if complex number, there will be a exponential, sorry, if there is no complex number, there will be an exponential decay. If there is complex number, there will be oscillation. So this
Same
you have
thing
to be
in
very careful.
AC. Same thing in AC.
In AC, I am talking about, yes, at the transient period, only at the transient period. In steady state, there won't be. There will be oscillation in the steady state, you know, according to the voltage that you are giving. So steady
Yes,
state
that's
output
what I
will
mean.
be different. Yeah, for the transient period, you can see additional oscillations. You can see something like your sine wave will not be perfect. There will be some kind of distortion in the sine wave. You can see some other oscillation is coming into picture, and it is mixing with it. Okay, so you can see something, some
Harmonics.
disturbance. Yes, some harmonics. You can see some kind of distortion at the beginning. Okay, so that kind of harmonics you can see. So what we can do is that basically the solution of the differential equation I of t, you will get this form, basic form I am saying. Let's say this is S1 is one root and S2 is another root. It is having A1 into e power S1t plus A2 into e power S2t. These are all roots, okay? Root of the equation.
Yes,
This
sir.
is the general form of differential equation. This is the solution.
This is current of what, sir? Of transient of
Is
or steady state?
this will give you the actually the transient response, and from the transient response, this is regarding the source-free circuit, okay? You will get the transient response. So this is the solution of the second order differential equation. Basically, this equation is basically characterizing, it is the solution of the second order differential equation. What is the solution of first order differential equation? First order differential equation is having a solution like this. This is first order. But second order is having two roots. Solution will be, you can say, instead of, if you have confusion, I will use two constant, K1 and another constant, K2. Okay. Now I think your confusion is over. Okay. So we have two roots now. Two roots now. You see here, you compare with this. E power S1t. What is S1? S1 is nothing but the pole of the system, right?
Yes.
And
Yes,
you know
sir.
time constant tau1 is nothing but 1 by S1. Remember this thing?
Right.
Yes,
Pole
I
and the
remember,
time.
sir.
So how it will be looking like? It will be also looking like e power t over tau1. Same like the previous case, in the case of first order, right?
Yes.
Since there are two roots, you will be getting like this. But if the root is like this is equal to k1 into e power minus alpha minus j beta, okay, or plus j beta into t
Into T.
plus k2 into e power minus alpha minus j beta
Minus beta.
into t. Okay, so you can see here both are having minus alpha, so e power minus alpha into t into k1 into e power j beta into t plus k2 into e power minus j beta into t. So what is this means? If there is a complex root, you are getting a phasor, you are getting something like e power j beta t. What is e power j beta t plus e power minus j beta t? Can you tell me?
What's the question,
I
doctor?
don't understand, sir.
Okay, did you understand what I have written the equation? E power minus alpha t into k1 into e power j beta t plus k2 into e power minus j beta t, right? And you know this, e power j beta t is
Yes,
nothing
it's
but
okay.
cosine of beta t plus sine of beta t, j sine beta t, and e power minus j beta t is nothing but cosine of beta t minus j sine beta t, right?
Yes, sir.
This we have. So what is happening here? You can see the terms like cosine and sine. That means you have oscillation. You understood? You
Yes,
will be
sir.
having oscillation. So the exact solution, it's very complex. It will depend upon different problems according to the value of R, L, and C. So you just need to understand that you can see a transient period. During the transient period, you can have some kind of harmonics, and after that, in the steady state, you will come to the original frequency. Okay, that is the main idea you have to understand. If
Yes, sir.
we will try to find the steady state response of the system. So this is the case. So this equation you can use in the transients, and you can also find that steady state response. So by using the combination of transient and steady state, you can find this constant k1 and k2. Okay.
Yes.
How to find
Yes, sir.
k1? Can you tell me how to find the k1?
T equals 0.
If you put t equal to 0, you will get a combination k1 plus k2. Am I correct? K1 plus
Yes.
k2.
Right.
Then
Then put K2 is 0.
if you put t equal to 0, you will get k1 plus k2.
No, K2 put it 0.
How? You cannot put it simply 0.
We can't, doctor. We can't.
How? We cannot put
Yes, we can't
simply
find K1
it,
like this way.
what will happen if I put t equal to infinity? If I put t equal to infinity,
No, doctor, it will not be okay.
it will not be okay if I put t equal to infinity.
Because exponential will be 0. K
Yes,
will be
exponential will be
anything.
0.
Can
It
be
all will be
anything.
0.
Who told you infinity? E power j infinity is infinity?
No, it will be 0, sir. 0 multiplied by K can be anything.
If I put infinity,
If you
e
put t
power
equals infinity, doctor, the
what is
first
e
one
power
t
j? What is e power j infinity? It's nothing but cosine of j infinity. Sorry, cosine of infinity
yes.
plus sine
Yes,
of infinity. What will be the value of this? Is it possible to define?
No, sir, no.
It's not possible. So what you will do?
I have no idea.
Hmm? No idea?
I have no idea, sir.
You have a single equation which is a function of time. Okay. So you will first put t equal to 0, then you have I of 0 and you have f of 0. You can got it. But you have two constant k1 and k2. Now you will take another time. Let's say you will put
What is F?
this
What
beat.
is F here?
The function.
From where we get F, sir?
No, I'm just saying this function. This is a function. The total thing is a function. I of t is a function of time, right? I of t is a function of
Yes,
time.
sir, yes.
I'm just writing
Yes,
like
sir.
this. Now you will consider another time. Let's say t equal to some t1, and you will find I of t1. What will be the value? You will write the equation in terms of k1. That's it contains not only t, it contains k1 and k2. And also here also this is a function of this is a function of, now you see here it's a function of k1 and k2, and here also you will see it is a function of not 0, it is a function of t1, k1 and k2. You got it? So you will observe at two different times.
Yes, sir.
After that,
But doctor, at I
yes,
equal I at T1, we don't know the value of I of T1.
yes, we don't know the value of I at t1.
How can
So
we
we
solve
will
the question if we don't know?
yes, so what we will do in such a situation, actually we will first focus on if we consider, suppose for example, you consider this beta t is equal to pi by 2. If beta t is equal to pi by 2, then e power it become, what will be the, for example, beta t is equal to pi by 2. If t equal to 0, I agree with you. If it is t equal to 0, it's difficult.
Okay.
So we have to, what I am saying is that I want to just say this thing. We have to use some kind of trick for getting k1 and k2 according to the problem. That's my concern. Okay. So we have to use kind
Yes,
of
sir.
trick to obtain k1 and k2. It's because we have two constants. We have to determine two constant. So that is the
Yes.
main concern. Okay, that I will, if time permits, inshallah, I will solve a problem or I will send you a problem. So that is about the RLC circuit. We cannot go very much in detail because it's a big analysis, and it will have, you remember in DC RLC circuit, we have lot of different cases, right?
Yes.
Yes.
Yes, we have
So
four
yeah, a
cases.
lot of different cases. So since because of this reason, actually we cannot go beyond that level. If I get some good materials which is explaining it in a very simple manner, inshallah I will give you.
Thank you,
Okay.
doctor.
Okay.
Thank you,
So
sir. Thank you.
so I will give you one more thing now. Okay, this is the idea. So inshallah we will continue with the tomorrow. Inshallah we will take the phasor diagram. Till now we have seen what is phasor representation and all, how to draw it. Have you studied this topic before? Phasor diagrams?
I have studied on YouTube, but in the university,
Doctor, I didn't understand anything of it.
In the last lecture, we have seen what is phasor. Okay. Yesterday, we have seen what is phasor and how to analyze RLC circuit.
Sir.
Not RLC circuit, we have seen RL circuit and RC circuit. Now we will
I remember
see.
also we studied in measurement.
Yeah.
Measurement, Dr.
And how there is something known as phasor diagram. Phasor diagram. And by using this diagram, we can find the magnitude and the phase of the resultant current or voltage, whatever. Okay. So inshallah that we will see in the next lecture, inshallah. Okay.
Inshallah.
So by using that, we will solve some circuit. And after that, there is only one topic is remaining. That's what I am designing to complete with. That is the resonance. Okay. I just need only one lecture. I will give you a feel of resonance. It's a big topic. That's why. So I will give you a feel of resonance, inshallah, what is resonance. And with that, we will conclude. Okay. Is it okay?
Yeah.
So maybe,
yes, sir, no problem.
Maybe, inshallah, 2 lectures I need, maybe, inshallah. Okay. Apart from the tomorrow's lectures, one more lecture.
No problem, sir.
Okay.
No problem.
And with that, I will conclude. Okay. So RLC circuit analysis is very complex because it will depend upon 2 constant K1 and K2, and you have to obtain the solution. But you can write the differential equation and solve it. It is not a big issue. If you know the equation I have given you for DC, if you analyze by using those equation, and if you know the Laplace transform, then finally you can get the answer. It's not a big issue. Okay. But it's a very big derivation. So
Right.
That's the case. So in RLC circuit, we have different cases according to the roots of the characteristic equation or the pole. Okay. So according to the pole, actually everything will change. That is the problem. Okay. Inshallah, tomorrow we will see. Inshallah, we will see.
Yes, sir.
In the next lecture. Okay. So RLC circuit is very complex anyway. That's what I want to tell you.
Yes.
It will be having harmonics according to the location of the poles. Okay. If the poles are real, you cannot see that much harmonics. You can see
Doctor,
a distortion.
We took
small.
a simple way to solve RLC circuit. In Dawa'ir الاثنين.
Sorry, RLC in Dawa'ir الاثنين.
Yes, but
okay.
not basics.
Yes.
We didn't take basics. We only jump to the solution.
Yes, this what I am saying is that just working with the formula is very easy. Nothing is there.
Yes.
But why I'm saying about the derivation, the complete derivation of the thing. Okay. For completely deriving the whole circuit, it will take some time. That's what I'm saying. That's why I'm skipping this portion.
It's too long.
If time permits, I will give you, or otherwise I will make a video lecture and I will upload it in the Blackboard. Okay. Because next week it is difficult for me. That's why. Next week I have to do a lot of work. That's why. University works are there. That's why. So inshallah, I will give you a feel of RLC circuit by using phasors. Steady state response is very easy in RLC circuit. You understood, Majid?
Yes, doctor. Yes.
Steady state is not a big issue. It's very easy that we will see how we can solve it by using the phasor diagram. It's very easy. It's not a big issue. It's like simple circuit.
Diagram is about vectors, right, doctor?
Yes, vectors. So by using a phasor diagram, it's very easy to get the steady state solution. I am saying about the transient. Transient is a little bit complex. That's what I'm saying. Okay.
Yes.
Okay. Inshallah, we will see tomorrow the steady state analysis. And if time permits, inshallah, I will send you materials
sir.
on the transients, AC transients, inshallah. Okay.
Okay.
Okay, thank you.
Inshallah. Assalamu alaikum. Welcome.
عليكم السلام ورحمة الله.